Hey guys, welcome to your Chapter 3 Lesson 4 notes on solving multi-step inequalities. What's great about today is it's basically the same thing as solving multi-step equations with a twist. So our key idea of the day is that you can use the properties of inequality to transform an inequality into a series of simpler inequalities, but they have to be equivalent inequalities. Inequalities. This is the same process as solving equations. So basically just treat it like an equation. So here we look at this guy. To start out, we've got 9 plus 4t is greater than 21. And our goal is always to get t by itself. So to undo what's happening to t, we're going to subtract 9 from both sides. And that will get rid of the 9 plus. So those cancel out. We're left with 4t is greater than 21 minus 9, which is 12. And now we have two equivalent equations. This guy right here, 9 plus 4t is greater than 21, is equivalent to 4t is greater than 12. So our next step is just solving this inequality. Here we're still trying to get t all by itself, so to do that we're going to divide by 4 on both sides. These 4's will cancel out, giving us t is greater than 3. And that's our solution. Now to graph our solution, we're going to put all of our values on a number line. I like to put 3 right in the middle, and then I look at this t and I see, okay, t is greater than 3. That's strictly greater than, not greater than or equal to. And then as long as t is greater than 3, we will be going this way. T is greater than 3. Now let's check to see if this worked out. Let's check by plugging in 4. Is it true that 9 plus 4 times 4 is greater than 21? Well, I don't know. Let's find out, shall we? 4 times 4 is 16, and 9 plus 16, is that greater than 21? Well, 9 plus 16 is 25, and yes, 25 is in fact greater than 21. So we did it right. Super duper. Now let's check our next equation. So here we have this equation, negative 6a minus 7 is less than or equal to 17. And our goal here is to get a all by itself. And make sure that you are listening carefully to our ed puzzle, because the keyword today is confetti balloons. We celebrated my sister-in-law's birthday and my nieces were super excited about confetti balloons. So that's very exciting. We're going to talk about those confetti balloons later. Anyway, we want to undo this minus 7, so we're adding 7 to both sides, giving us negative 6a is less than or equal to 24. And now look at this guy. We have a simpler inequality, but we are going to divide both sides by negative 6 on both sides. And remember from our last lesson, since we're dividing by a negative number, we need to do our math with a twist. So we need to flip our less than or equal to around. This guy's going to flip around to a greater than or equal to. Our negative 6's cancel out on the left, giving us a is greater than or equal to negative 4. Let's graph our inequality and see if we did this right. So we've got negative 4, negative 5, negative 3. And since we have greater than or equal to, that gives us a solid circle on our negative 4. A is greater than is going to go this way. So let's check our work. Is it true that negative 6 times negative 3 minus 7 is less than or equal to 17? Well, I don't know. What is negative 6 times negative 3? Okay, is 18 minus 7, is that less than or equal to 17? Well, that's 11. So yeah, 11 is less than or equal to 17. It's the less than part. So yay, we did it right. That's your key idea. Now, when are we going to do this in real life? Well, I'll till you, get till, like a garden, but tell, it's a pun. Okay, anyway. So in the Whittier Christian Community Garden, you want to fence in a vegetable garden that's adjacent. Adjacent means next to. So it lines up, it shares a wall with. So you want to put a garden next to your friend's garden. You have at most 42 feet of fencing. What are the possible lengths of your garden? And yes, please excuse my hiccup. Let's look at this guy right here. You have at most 42 feet. That means if F is the amount, if F is the amount of fencing, that means F cannot be greater than 42. You can use 40 feet of fencing. You can use 1 foot of fencing. It's a very tiny garden. But that means F has to be less than or equal to 42. Actually, I lied. Don't use F right now. Just whatever we're going to use is going to be less than or equal to 42. Okay. And we also know, based on this picture, that it can be at most 12 feet long. And we're also assuming that it's going to be exactly 12 feet wide, because all of these gardens are 12 feet wide. We just need to figure out how long can the garden be. Let's make that blue, I guess. We want to find out how long can our garden be. And in making our garden, let's just do this in like gray. In making our garden, it's going to be a rectangle. So we need to figure out how much fencing to use, and our fence is going to be represented by the perimeter of a rectangle. So perimeter of a rectangle, you remember that P equals twice the length plus the width. Because we have two widths here and 2 lengths here. So in this sense, the perimeter is going to be twice the length of the garden plus twice the width of the garden, and that's going to be at most, because up here we said the fencing needs to go up to at most 42 feet. So twice the length, twice the width is going to be at most, at greatest, the amount of fence, giving us our less than or equal to symbol. So let's let L, we already said that L already. L is going to be the length of the garden. Well, what do we know? What do we know about our garden? Well, we know the perimeter is 42. And we know it's going to be up to that. So I did switch this around. If it's less confusing, we can move this guy around here. Let's do like that. And that means that our perimeter is here, and however much fencing we use, that's going to be up to or equal to 42. And we know, what else do we know about our garden? We know that the width of the garden is 12, because that's how wide the garden is. Look up here, it's 12. It's 12 feet wide. Okay. Yay. Now we need to figure out what are the possible lengths. So first let's distribute that 2 in. We get 2L plus 24 is less than or equal to 42. And since we're trying to get L all by himself, we'll subtract 24 from both sides, giving us that 2L is less than or equal to 18. In our final step, we'll divide by 2, so L is less than or equal to 9. So what does that mean? That means that the length of the garden, sorry, this is just taking a long time. The length of the garden must be 9 feet or less. That says less. Okay, so our garden can be up to 9 feet wide. So it's less than or equal to 9 feet. It can be smaller if we don't want to use that much space, but we can go all the way out to 9 feet. I think the hardest part here is just setting up the formula and then plugging in what you know where it needs to go. Okay, let's do 2 more examples. Oh, but you guys, I struggled. This should be example 4. Well, strictly speaking, this is example 3 and 4 at the same time. So here you go. So what happens if we have a really complicated inequality? Well, guess what, guys? It's the same thing as having an equation. All we want to do is simplify each side. So first, I'm going to use the distributive property to, wait for it, distribute the 3 to the t and the 1 in here. So it gives us 3t, oh dearest, I wanted to use black. 3 times t plus 3 times 1 is 3. It's greater than or equal to 4t plus 5 cannot be simplified, so we're going to leave it as 4t minus 5. And now, we want to get all the variables to the same side. But you know what, guys? I'm going to go backwards real quick and show you what I just did. So we did 3 times t plus 3 times 1 is greater than or equal to 4t minus 5. This is because we took this 3 and distributed him 3 times t plus 3 times 1 to the t plus 1 right there. Next, we want to take this guy and we want to get all the variables to the same side. So what I'm going to do is I'm going to subtract this 3t from both sides. So if I'll just copy this down here real quick. Boom. And I'm subtracting 3t from both sides. This will get variables on both sides. Or sorry, I'm just on one side. So those cancel out, leaving us with just 3 is greater than or equal to t minus 5. Yay, we're almost there. And now we want to get t all by itself. So I'm going to add 5 to both sides, giving me 8 is greater than or equal to t. That's super. 8 is greater than or equal to t. And now let's graph it and check our answer. So we have 8, 7, 9. We have a greater than or equal to. So that's a solid circle. And if 8 is greater than or equal to t, let's check. Does 7 work? Well, 8 is greater than or equal to 7. So yes, so we're going to go this way. Ta-da! Because 8 is greater than or equal to 7. Now let's check way back in our original equation and see if we did it right. So our original, and by equation I mean inequality, of course, says 3 times t plus 1 is greater than or equal to 4t minus 5. Let's check. Does that work with 7? Oh, I guess I should have made my whole solution yellow, because I always do. Okay, now 7. Will it work if we plug in 7 here? Well, you tell me. Is it true that 3 times 7 plus 1 is greater than or equal to 4 times 7 minus 5? Let's find out. Well, is 3 times 8 greater than or equal to 28 minus 5? Well, 24. Ooh, we're cutting it close, you guys. Is greater than 23. It is. Ooh, that was, oh man, that was intense. But we got it. Yes, we did it right. Okay, we have 2 more. And they're going to be a little special. So here we go. Okay, I see that we have some variables on both sides. And I also need to start out with some distribution. I almost said that really weird. 2 times 5 is 10, minus 2 times 4 is 8, so we have 10 minus 8a, 10, oh dear, I can't even write 10 correctly, 10, oh, wow, okay, well, guys, we have the same thing on both sides, and if we wanted to, well, we could subtract 10 from both sides, giving us negative 8a is greater than or equal to negative 8a, but either way, since we have the same thing on both sides, and we have this equals guy in here, this is always true. Yeah, this is just like, yes, yeah, yes. What do we do there? Well, guess what? If we have a statement that's always true, then the solution, we say, is all real numbers. This is because no matter what we plug in for a up here, it will always be true. If a were 0, Well, 10 minus 0 is greater than 10 minus 0. Right? It works for every single number. Sometimes inequality gives a statement that's always true. In that case, the solutions are all real numbers, and that's what you write. That's your answer. Yay, we did it. All reals. Let's check out this one. What will happen over here? Well, first I'm noticing that we have two like terms over here, so I need to combine those real quick. 7m minus m is 6m. So we have 6m plus 7, 6m, 6m minus 5. You guys, what if we like subtracted 6m from both sides or something? Shoot, we're left with negative 5 is greater than 7. And that's a lie. That's false. This can never be true. So we call this no solution. There is no value of the variable m that will make this true. No matter what number we plug into here, this is never true. This is always false. So sometimes you'll get an inequality that is never true. When that happens, you just say, oh, hey, sorry guys, but this is no solution. And that's it. Because we like when there's all real numbers, we'll make that green, and we'll color code this to be red because we like color coding. But anyway, yeah, B has no solution. So if there's no way this is ever going to be true, it's got no solution. This one, no matter what you plug in for A, it's always true. And basically, the key idea of the day is treat inequalities like equations and solve them, and you'll be just fine. Remembering, of course, sometimes we have a little twist where you divide or multiply by a negative number. You got to flip your symbol around. I hope you have a fantastic time on your homework.